So today's lesson is on states of matter. Um, so we're going to be talking about solids, liquids, and gases. I have gauze in my mouth, so you'll have to forgive me. I went to the dentist today. So, solid is a substance that is not easily compressible and does not take the shape of its container. And these are the two characteristics we're going to look at for each of the three. And so now what I'm going to do is try to explain why solids are not easily compressible and why they don't take the shape of their container based on their microscopic properties. So the particles in a solid, and whenever I say particles, I mean atoms, molecules, or ions, whichever that substance is made of. The particles in a solid are tightly packed. They're so tightly packed that you can't push them closer together, which is why a solid is not compressible. And they're also so tightly packed that you can't move them around one another. And so I guess one way to think of it is like those vacuum sealed packs of coffee. They come kind of like in bricks sometimes, or at least they used to. The coffee grinds, and they're so tightly sealed that it feels like a solid brick. But then when you cut it open, you can swirl the coffee grounds around, and you can see they're separate little pieces. So when it's tightly packed like that, the pieces can't move around each other, so the coffee grounds can't change their shape. Well, it's the same thing here. These are so tightly packed together that they can't move around each other, which is why you can't pour a solid or why it doesn't take the shape of what you put it in. A liquid is a substance that's not easily compressible also. Most people don't realize that, but if you take something like a pump and fill it with water and hold your finger over the top and try to squeeze it, you'll see you can't do that. Or you could use a syringe without the needle on the end. Just take the needle off and put your finger over the end of the syringe and fill it with water, and you'll see you can't compress the water. You can compress air, but you can't do it with water. So water can't be compressed. Its volume can't be decreased easily unless you had a tremendous amount of force. But water does take the shape of its container. And whenever I say take the shape of its container, we should also think that means that it can be poured. If something can take the shape of a container, it can also be poured. So what's the reason for this? So the particles are pretty tightly packed, but there's enough room that they can move around a little bit. So imagine like a jar of marbles. Each marble would be like one atom or one molecule of a liquid. You can, if you put your hand on top of the jar and try to push all the marbles down, you can't squeeze them into a smaller space. You can't decrease the volume. But if you put your finger in and you swirl it around, you can move the marbles around one another. And if you pour the marbles into a different shaped container, even though each individual marble is still round, the pattern that all the marbles make together will be the shape of the container. So this is how liquids act. If you imagine the atoms, the marbles being like tiny, tiny atoms, right? If the marbles are small enough, then a huge amount of marbles would take the shape of its container. A gas is a little bit different. Gases are the only ones of the three that are not easily compressible. So that's how you can tell the difference between a gas and a liquid. If you can squeeze it into a smaller volume, if you can put it into a pump or a cylinder and squeeze it into a smaller size, then it's a gas. If you can't do that, then it could be a liquid or a solid. And gases, of course, take the shape of their container. The gas in this room is taking the shape of this room. If you put gas into an oxygen tank, it takes the shape of the oxygen tank. Heavy gases can be poured, right? If we had a CO2 sitting inside of if you go buy a block of solid CO2 and you let it start to evaporate in a bucket, you can pour it out of the bucket. Now it's a gas at that point because it is compressible, even though you can see it. But it's a heavier gas, so you can pour it into things. So gases act this way because the particles are so far apart. If you look at this picture, these little dots here, they represent either the atoms or molecules of gas, whatever it might be, usually molecules. And you can take them and you can squeeze them much closer together. That's why you can compress a gas, because you can push the atoms closer together. It would be like if I took 5 or 10 marbles and spread them out on the whole table. You can push them closer together and make the volume smaller, those 10 marbles. And of course, since they're so far apart, they very easily take the shape of their container. You can pour them very easily. Okay, so at this point, if we were in class, I would demonstrate using some sort of compressing tool, either a pump or a syringe, how you can compress gases and you can't compress a liquid like water. So in closing, here's the three. Solids are very tightly packed. Liquids are somewhat tightly packed. Gases are barely packed at all. And those three things determine their two properties, their two macroscopic properties. That solids cannot be compressed and can't take the shape of their container. Liquids cannot be compressed, however they can take the shape of their container. And gases can be compressed and can take the shape of their container.